Hello, let's continue our Sudoku adventure with Jeremy by Palfly Kampling. So this is the final puzzle of our Region Sumlines theme week. I hope you enjoyed the week. If you are coming in to this late, this entire week we have been doing puzzles with Region Sumlines. So if you enjoy this constraint, there is plenty more to do. There is also a tracking sheet available which lets you go through every single adventure, includes links both to the puzzle as well as a link to my walkthrough video. And also it has abilities to filter and sort and all sorts of good stuff if you want to find specific puzzles to solve. So yeah, definitely check that out. And so yeah, let's go over the rules to this puzzle. We do have normal 6x6 Sudoku rules, meaning in every row, every column, and every 2x3 box. We are placing the digits 1 to 6 exactly once each. We also have lines in the grid that are both region sum lines and between lines. So, region sum line first. What we do is we need to divide our region sum lines into segments, and the segment borders are where the box borders are. So this line, for example, would be in 3 segments, which I'll just color code. So we've got the orange segment, the green segment, and the purple segment. Now, within the same line, segments sum to the same amount. So the sum of the orange cells is the same as the sum of the green cells, which is the same as this singular digit in purple. So if this was, say, I don't know if an example will be good here, but if this was, say, a 6, then these would add to 6 and these would add to 6. In addition to that, these are also between lines. So that's what these circles are at the ends of the lines. So the line is considered, for the region sum, the line is considered to include the circles, but between lines, you have a line with the circles at each end. So the circle ends are kind of the bounds of the rest of the line. So if this was, say, 2 and 6, these need to be between 2 and 6. So they'd have to be from 3, 4, 5. Hopefully that makes sense. But in addition to that, we do also have to follow region sum line rules. So keep that in mind. All right, so basically the rule is the digits on the line are strictly in between and not equal to the digits in the circles. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. I do want to think about this because this seems quite limited. The first thing to think about is, what is the minimum sum of these 4 digits? And the minimum I could put in here is 1, 2, 3, 4. 1, 2, 3, 4 does sum to 10. And so if these sum to 10 minimum, this digit here needs to be half that because it is the same as this sum and this sum, which are the same sum, right? So we're going to be dividing these by 2, and that's the sum that goes in here, the digit that goes in here. So this has to be a 5 or a 6. Now, if you think about it, if this was a 5, these would be 1, 2, 3, 4, adding to 10. But what does the entire column add to? The entire column always adds to 21. All rows, columns, and boxes add to 21 because they have 1 through 6 on them, once each. And that adds to 21. So if this is 5 and this is 10, that basically this times 3 is the sum of the entire line because we have 3 segments. So that'll be 15. So we need another 6 in order to get to 21. If this was a 6, we'd be 6 times 3, which is 18. And so then this would have to be a 3 in order to get to 21. So not only is this 5, 6, but this is 3, 6. Now, obviously, this is the larger end of our sum, of our between line, right? Because this is also between line. 5, 6 is going to be the bigger end. I'm certainly not putting anything bigger here. We're not doing 5 and then here and then 6 here and then having digits between 5 and 6, 3 of them here. It doesn't make any sense. Now, if we think about it, we're only missing the 3 or the 6 from this entire line because that's what goes here. I can't put a 3 or a 6 here. If I try to put a 3 here, then I can't have 3 digits between 3 and 6. There's only 4 and 5 available. So even by the between line, this has to be the 1. Because we need a 1 in this line somewhere, and 1 cannot be smaller. Sorry, 1 can't be bigger than whatever this is. So this has to be the 1. And so now, if we add to 5, this has to be 1, 4. And if we add to 6, this has to be 1, 5. And so then now, if we add to 5, we can't use the 1. So this has to be 2, 3. And if we add to 6, again, we can't use the 1. So it has to be 2, 4. So there's always a 2 here. Okay. So I think we've gleaned as much as we could from this line. I don't even know if that's where we were supposed to start, but notice this line is the same. And now we have a 1 filled in here. Sorry, this line isn't the same. If it were the same, that would be bad. But notice horizontally, we only have 2 boxes, so there's 2 segments here. But we know what the segments add to, because remember, the entire row is 21. Sorry about that. That was weird. The entire row is 21, but it's missing the 1. So this adds to 20. 20 over 2 is 10, so each segment is 10. In order for this segment to add to 10, the only way to do that is 4, 6. We actually know the order, because this... If this was a 4, basically we can't ever put a 6 on here because nothing's bigger than 6 to put in the circles. So this is the 4, this is the 6. That does make this 5, making our sum 6. So that's 6 and 3. This is a 2, 4 pair. Nice. We get a 3 in the corner, deep dooting away. This is a 2, 3 pair. Up here we need 2, 3, and 5. Now, the 6 is the big side, so this needs to be the little side, so it's got to be the 2. In fact, we could have probably immediately filled in this 2 as soon as we knew there wasn't a 1 in the row. One of these had to be 2. But these had to add to 10. That wasn't going to work with a 2. So anyway, we have a 2 with a 3, 5 pair. 2, 3, 5 does add to 10, just double checking. This is 1, 4, 6. Now, I'm suspicious of the 4, but I think it works. Okay, so what else are we doing here? This between line might be interesting. This digit, just by definition of the region sum line, is bigger than the sum of than each of these individual digits, because the sum of these digits is this one. So this is the larger end, and this is the smaller end of our between line. So you can kind of think of it like a thermometer. This is the smallest digit, this is the medium digit, this is the largest digit. I don't have enough restriction on this to like tell you what that is though, but I thought I'd point that out. This 4 does look down into here, putting a 4 in one of these two. And let's see. What else can I say about this? Can this be a 4? I'm not sure. Let's think about this line in general. These 3 cells sum to these 2 cells. These 2 cells at maximum are 5, 6, which is 11. So these 3 cells cannot exceed 11. Now the minimum we could do is 1, 2, 4, which is 7. So that seems like quite a bit of range of options. Okay, so what are we doing here? Okay, we do need a 3 up here somewhere. I would argue this can't be a 3. Because if this was a 3, remember, we're getting bigger as we go. So this would have to be 4, and then 3 plus 4 is 7. That doesn't work, right? This number has to be bigger than the 3. This is the small end of our between line, so this has to be bigger than 3, and that just doesn't work. If I make this bigger than 3, this is going to add to more than 6. So the 3 doesn't go here. Now these 3s line up, telling us that this column needs a 3, which is going to end up over here. I don't know if that logic was necessary, but I found it. Now what if this was a 3? That seems perfectly viable. This would have to be lower, can't be a 2. So we'd be 1 plus 3 is 4. That's what would happen if this was a 3. And that seems perfectly reasonable to me. Okay, we do need a 6 down here. So as I said earlier, you can't ever put a 1 or a 6 on a between line. It has to go in the circle if it's going to be on the line at all. So 6 is one of these two. This being 6 seems reasonable. It would remove the ability for this to be 4, I think. Let me think about that. So if this was 6... and this was 4, we'd have to put 5 on all 3 of these. Yeah, that doesn't work. So only one of these can be true, if either of them is true. I am clearly missing something obvious. Maybe it's this line. I haven't looked at this much. So again, okay, yeah. So we have the same logic here, where the sum of these two is this digit. So this cannot be a 1. So, and then they're going to go in order, because this needs to be the low end now. I can't do 4 here with bigger numbers here. So there's smaller numbers than here. Whatever this is, these are smaller than it, which means this is the smaller end of the between line. So with the 4, we'd be 1 plus 3. That would be exactly 1, 3 like this. With the 6, we could do 1, 5, or we cannot do 2, 4 because there's a 2, 4 pair here. So actually, this is always a 1, which is interesting. Because we only get 1, 5, or 2, 4 for the 6. Definitely can't do 2, 4. And then for 4, it's only ever 1, 3. Can't do 2, 2 for a lot of reasons. Not the least of which is that you can't repeat 2 in the same row. So these end up being 2, 3, 4. These can't be 3, so that places the 3. Places the 2 and the 3. That's 5. 1 plus 5 is 6. So I was looking at the completely wrong... Oh no, I must have marked something wrong. Right, there's 4 digits left in this column. What am I doing? Anyway, 2, 3, 4, 5. These aren't 3. I want to say this has to be the lower end, but I don't know that that's true. If this is big, if this is the bigger end, it puts a lot of pressure on the sum, though. Right? If this is big, this has to be the smallest digit on the entire line, and then it has to be plus something that can't even be 6. Can't even be 5. Yeah, that doesn't work. Okay, this is my proof that this is not the big end. If this was the big end, let's make it... I don't even know if making it big is useful, but the idea is if this is the big end, it's certainly not 2, right? But let's not even worry about that. If this is the big end, this is the small end. If this is the small end, what was I thinking? How small could it be? I guess is the first question. So we could put a 5 here. Let's actually do that. We could put a 5 here. I'll just do it small. 5 here. Let's not worry about what these would be. And then the smallest I could make this is, well, sorry, the biggest I can make this. I want to make this as big as possible. We could go 5, 4, 3. So this would be 2 at its biggest. And now the issue is that this digit needs to be 3 larger than the sum of these two. And that's not possible, right? Because these two would be minimum 1, 2, which is 3. And then this would have to be 3 larger than that. This would have to be a 6. So that 1, 2, 5 adds to 8, and 2, 6 adds to 8. Now, making 5 smaller doesn't help, right? And making 2 smaller certainly doesn't help. So the difference between these two is at least 3. That's kind of what we're going to start with, right? The difference between these two is at least 3 because we have 2 distinct digits here. So this needs to be 1 larger than that at least. And then this needs to be 1 smaller than that at least. And so again, 5, think about the example of 5 and then 4, 3 would do that. And so whatever these, so that's a difference of 3. So this needs to make up that difference. It needs to be at least 3 to do that, but then it needs to be big enough to account for whatever the minimum we could put here. Can't even put 1, 2 there. So there's just so many reasons. Hopefully at this point you kind of understand that it's absurd to say that this is the large end. So this has to be the small end. So that's a 2. Because 4 doesn't work. We'd have to do 5, 6 here. And then there'd be nothing here. So it's the small end. That's a 2. That's a 4. Okay, that's 3 and 2. That's 5. That's 3. 1 plus 3 is 4. These aren't 4s. That places the 3 there. Okay, this is also a pair. And the 1, again, cannot ever put a 1 on a between line. So that's 1. And then that's 5. So this adds to, this is big already. This is 9 plus 2. That's 11. That is the absolute biggest this could have been. That's 6 and 5. So that's 1 and 6. That's 3 and 5. That puts a 3 here. Over here, I do need a 1 and a 2. And this 2 tells us the order. That's 1, that's 2. That adds to 4. That is a 4. So actually, I was trying to prove this couldn't be 1, 3, 4, but it ended up being that. So that's why I couldn't prove it. That's a 4. This is 2 and 4. We're just finishing now. This is a 6. Here we need a 1. Up here we do need 2, 5, and 6. The 2 goes here. The 5 goes here. The 6 goes here. All right. Yeah, it took me a little bit to... I don't know. I think I spent too long proving this had to be low. I think it was pretty obvious that this had to be the low end. But it was more of like an instinctual thing. And then proving that it had to be low. I think there was a lot of ways to do it. But we could have just fiddled with the digits and just proven that it had to be low. But I think I like the generic proof that this could have never been the low end. Because these need to have a difference of at least 3 from each other, right? Whatever these are, if they have a difference of 2, like from 2 to 4, for example, or 1 to 3, right? There's only 1 digit in between them, and we need 2 digits in between them. So they have a difference of at least 3. And that means that this cell, if this was the low end, this cell would need to make up that difference of 3 plus the sum of these two And that would put a 6 here at minimum. And a 1 on here. And you can't put 1s or 6s on here anyway. So yeah, there's no way that works even right from the start. We know this is the high end, this is the low end. So I don't know if that helps with the proof, but that did seem pretty necessary to finish the puzzle. But you probably could have just plonked and seen that, okay, 4 and 5 just don't work at all. There's no way. So anyway, hope you enjoyed this. If you did, then why not leave a like, subscribe, and a kind comment below.